We're moving on to multiplication of matrices. Alright, so if you have two matrices, matrix A and B, multiplying each other, we say that matrix A is pre-multiplying and matrix B is post-multiplying. Right, so if you have your two matrices multiplying each other, the one to the left is the pre-multiplying matrix and the one to the right we're saying is the post-multiplying matrix. You need to know that with two matrices multiplying each other, A by B, it's not necessarily true that you'll get the same result with B multiplied by A. If you can recall what we call the commutative rule, according to the commutative rule, you know, like in with algebraic terms, with the commutative rule, if you have your A multiplied by B, then this will be equal to B multiplied by A. That's the commutative rule. This applies to arithmetic and algebraic terms, but may not necessarily apply to matrices. So we are saying here that A multiplied by B, where A is the pre-multiplying matrix and B is the post-multiplying matrix, is not equal to B times A, where B is the pre-multiplying matrix and A is the post-multiplying matrix. So you need to understand this. This is very, very important. The commutative rule in this case with matrices does not apply. Alright, so you need also to know that not all matrices can be multiplied. Right? Say you have your matrix A, where A has the order P by Q. So A is a P by Q matrix, and it's multiplying matrix B, where the order of a matrix B, say, is Q by R. Right? So in order for you to determine if these two matrices can be multiplied, you check their order. We're saying A is a P by Q matrix and B is a Q by R matrix. So with the order or the dimensions of the two matrices, if the two matrices can be multiplied, these two values must be the same, like we have Q and Q right there. So if those two values are the same, then it means that the two matrices can be multiplied, and the result will come out as a P by R matrix. So these two other outer values right there will give us the order of the result. So that means that the result will come out a P by R matrix. So this is some important stuff right here. For example, let's say we are multiplying two matrices. Let's say we have the matrix 1 2 and the matrix 1 4. Right? The order of the first matrix is a 1 by 2 matrix. Remember, 1 row, 2 columns. And the order of the second, that's a 2 by 1 matrix. Remember that these are 2 rows and 1 column. Right, so with the order of the two matrices, we are saying that the values here should be the same, and in this case they are the same. We've got a 2 right here and a 2 right there. So because those two values are the same, that tells us that these two matrices can be multiplied. Right? But had they been different, that would mean that we cannot multiply the two matrices. And we're saying the result will come out being a 1 by 1 matrix. The result, we have the order 1 by 1. Right? And maybe just one more example. Let's say you have your two matrices multiplying each other. Right, the first matrix has got 3 rows and 2 columns, so that's a 3 by 2 matrix. The second matrix is a 2 by 2 matrix. Right, the two values here are the same. Right, so that confirms to us that the two matrices can be multiplied, and the result will come out being a will come out as a 3 by 2 matrix. Right, so that's very important for us to know. We're saying that the number of columns in the first matrix should be equal to the number of rows in the second matrix for the two matrices to be multipliable, if we can say that. So that is how we can determine if two matrices can be multiplied.